right, continuing on with our periodic functions. Okay, our goal today is I can understand what a periodic function is and can determine its key features. And with that comes I can graph y equals sine x. So that is something that is different for us in a sense. Okay, and I'm just going to switch my pen back to something nicer. Okay, so just a really quick review of the terminology. We talked about this before. Remember, we said that a period is like a stencil, and it's like how long is our stencil? And you can see our stencil is this. Well, it would be that kind of length. My pen isn't going exactly the way I want it to today, but that's fine. Okay, and then it repeats itself. Okay, and so when we're talking about measuring the cycle, we're talking about the horizontal distance, so the distance from there to there. So that is what we're talking about when we're talking about a period. Okay, the next thing that we talk about is amplitude. And amplitude was from the highest to the middle, okay? Or we talked to you about it being half the complete height of the graph. Okay, so now what we're going to be looking at is we're going to be looking at specific graphs that produce this type of wave. And what we're going to be studying is the sine graph. Are there other ones? Yes, there are. Cos graph actually looks very similar to sine graph. However, we're not responsible for that. So this is, I'm just going to read this to you and highlight anything that I think that's quite important. So to start with, as the angle of rotation, x degrees, increases, y equals sine x changes in a regular and periodic manner. So what we mean by a regular and periodic manner, remember when we talked about coterminal angles in the sense that in different places you end up with the same ratio? That's how we're getting this regular periodic manner. And we'll talk a little bit closer about that. So what happens is when we're graphing, we transfer the values of y equals sine x to a horizontal axis. So just like this, a horizontal axis. And with that horizontal axis, the x is measured in degrees and the y are the values of the trig ratio. So those are the numbers that you get when you put like sine of 30 into your calculator and you get that answer. So those are our y values. So the first thing we're going to do is we're going to look at an actual unit circle. I did give the link here so that if you want to look at it closer yourself, you can. Okay, and what's going to happen here, just before I start it, is the angles are measured in green. And so that's, in other words, that's our horizontal axis. And the y, the trig values, are actually in blue. So we're going to take a look at it and we'll run it through a few times just so that you can see what's really happening. Okay, so here's this little applet. So what's going to happen, remember, as I said, if we're going to be going around, so we're going to be increasing our values of our theta, okay? And those values are going to be transferred to the x-axis. And the measurement that we're going to be looking at is what's going to be graphed, okay? So you can see that as x goes around, so as we go around and we're making our theta, what's happening here is we're moving along the x-axis in the green. And what we're actually graphing is the blue part, which is represented by the y-axis here, and that's being graphed, transferred to here. So you notice that we'll soon be at 0, and if you notice when the green is at 180, we're at 0 for our sine, and we're going down into the negative values on the y-axis of the unit circle. And then we still are in the negative values, but we're starting to go up. That blue line is starting to increase again, and it's going to get again to 0. And the reason this is periodic is because we went around the circle once, but we could actually keep going around the circle, and those values that you're seeing here would be transferred and then it would go on and on. So let's reset it and we'll do it one more time. Sorry, I can't speed it up. Okay, so again, as the theta increases, you can see what's happening to the ratio of sine. So at sine of 90, we get the number 1, and then we slowly come back down again. We're still positive y values on the unit circle. When we get to 180 degrees, we end up having the sine of 180 as being 0. And now we have negative values for theta between 180 and 360. Our lowest point is going to happen at 270 degrees. Notice what's going back down to 270, and then it starts going back up again closer to 0. Okay, so you can play around with that yourself if you want. You can see that this applet, you could do also cos and you could also do tan. And in a minute, I'm just going to click on, there's cos, for instance, looks very similar, starts in a different spot. Tan is a really weird one. Okay, so you can actually go play with these yourself a little bit. All right, so back to our note. Okay, so that was what was going on here. And now what we're going to do is we're actually going to create a table of values for our function, and we're going to then graph it the same way that the applet graphed it, well, as close as we can. All right, so our x is going to be, as I said, in degrees, and our y, the way we get our y is from y equals sine of our x values. And for some reason, my little thing doesn't want to work very well today. Okay, so we're going to start at 0 degrees. Now we're not going to do every single one of these, but we'll do 45. We'll do 90, 135, 180. And then if you don't mind, I think we'll skip down and we'll do 270. Oops, 270. And then we'll go back up to 360 just so that you can see what's going on. Okay, so these are in degrees. We're going to pull up a calculator so you can see what's going on with that. Okay, so here's our calculator, and I've made sure that it's in degrees. So I'm going to take the sine of 0, and it equals 0. Okay, so I'm just going to put 0. Okay, so it's 0, 0 at this spot here. Okay, the next one we're going to do is the sine of 45 degrees, and that is approximately 0.7. And so at 45, 0.7, here's 5, so approximately here, and again, I'm just kind of guessing, roughly. Notice it's not at 0.5. At 90 degrees, you maybe remember from the applet what it was, but it is positive 1. And then at 135, oops, yep, got it, 0.7 again. At 180, we have 0. Now, although I didn't do 225, I'll just punch it into the calculator so you can see that at 225. Notice it's a negative 0.7. And I'll just put that so it's down here in the negative zone. At 270, we're at negative 1. Okay, so you can see we're at negative 1. And at 315, again, we're going to be at negative 0.7. And then at 360, let's see what happens. So I'll just clear those again. So the sine of 360, I should be back at 0, which I am. Okay, so this is what we've created. So now all I need to do is draw a nice smooth curve the best I can, and hopefully I can do that. It's as smooth as I probably can get, and then back up again. All right, now we put arrows in both directions because we could have gone around the unit circle in the opposite way and had negative values for our theta. So we do have arrows at both ends. Okay, um, now we're going to talk about the properties, and I'm going to tell you about the easiest way to graph these. All right, the properties, the domain. Domain has to do with the x values. You can see that x, I could choose any number I wanted for my theta. So that means that it is in the set of real numbers or an element of real numbers. Our range is also a real number. However, you can see that the graph stays in between two values. And the two values that it stays between are its bottom value, which is -1, and its top value, which is +1. And that makes sense because it's the unit circle, and the unit circle has a radius of 1. So I can't get a different value than that. So +1. The maximum value of y is 1. The minimum value is -1. And now what I'm talking about, the important x values, these are the values where important things happen. So for instance, the middle of the graph is considered important, the top of the graph, and the bottom of the graph. So you can see that it's happening at 0, 90, 180, 270, 360. That's where I'm either in the middle, highest, middle, lowest. Okay, so that's happening actually every 90 degrees. So I can use 0 is important. Oh, isn't that lovely? No, you don't need to do that. Oh, and then you switch to green. All right, obviously my pen does not want to work nice for me today, so out comes the mouse. So 0 plus or minus 90, because I could go into the negative zone if I so wished. Then it was plus or minus 180, and I would be at the highest point. Then it would be plus or minus 270, which actually this would be at the middle point, 270, plus or minus 360. And we could keep on going if the pattern, if we wanted to graph more than around the unit circle once. Okay, so it goes on and on. But the important thing also to notice is that it's happening every 90 degrees, like the distance between here is 90 degrees. Okay, so the next part I was going to show you is how to graph these as fast as possible. Now, to graph them as fast as possible, what I do is I take dotted lines. So I have my axes, but then I create a dotted line. Oh, I should have done it this way. Straight line. Let's make it blue. And I'm making it dotted, and I'll make it not quite as thick as that. So I know, first of all, I'm not going to put a dotted line on the x-axis. I go up 1 because that's my amplitude, and I go down 1 because of the amplitude. And then every time I cross either the middle, highest or lowest, I put a little dot. Okay, so it's kind of like this ping pong ball that's going. Okay, and then it makes it actually very easy then to graph it. And you'll see that the next day when we actually start moving this around. So not a whole lot of work from your textbook, so you probably could watch another video and you would be fine.